All right, guys. I initially had Unit 6 exam scheduled for this week, but I don't think we've had enough problems or done enough problems. So put it in your calendar that it's no longer this Thursday, but on Monday. So next week. So, I mean, unless you guys feel like taking it on Thursday. No, we can't do it Tuesday. No.
We can't do the lesson we were gonna do on Tuesday on Monday instead.
Well, this was supposed to be, and no, ma'am. Here, let's just. I'm coming out of whack today, so.
Yeah.
All right. So put it on your calendar, guys, that we're gonna have an exam Monday. Unit 6. All Unit 6 is on the plate. It's a unit exam. I'll open up some AP Classroom so you guys can get some practice. That's a participation grade. Not everyone has done their AP Classroom, guys, just a heads up. That's a participation grade. It's just, you don't even have to really do it if you don't want to. You can just pick whatever. But I would like for you to take it serious. That way you guys can see where you guys are at. Okay. Any questions on any of that? All right, guys. Let's continue. We are now calculating average and area between curves. Hopefully it's not too much. Let's chat a little bit about calculating average velocity from your physics days. So I'm going to write average velocity. So average velocity, when you guys were in physics, was your displacement divided by time. Do you guys remember that? Okay. So in calculus, how does that look? So average velocity equals, and it looks like this. How do I get displacement? Integral from a to b of v of t dt divided by time. And usually here's how we make it look like. We make it look like this because it looks prettier. Average v equals 1 over, oh, by the way, the change in time is b minus a, right? So 1 over b minus a integral from a to b of v of t dt. This should be, maybe put a little triangle there for change in time. So the b minus a is the change in time, right? Change in time. Nothing crazy. Do you guys agree with this statement? Okay. So if I change the word and instead of saying average velocity, I say I want the average f value. What do you think? Use your context clues from above. So how do I find average of f? Yeah, that's it. That's your formula. 1 over b minus a to b of f of t dt or f of x dx. It does not matter. And that's how you find average. And notice we derived this formula. We just didn't give it to you. Now, before we start, do we know what average means? Okay. So, nothing crazy. How do you feel? Okay, let's do another one. Let's see if this one we can figure some stuff out. So I'm going to go like this, and now I'm going to go all the way to, I'm going to say this is y equals x. Y equals x. Here's 0. Here's 10. And maybe I did it, well, okay, I don't want to. What's the average value of y equals x from 0 to 10? No, that's not the average value. Yeah, what do you think the average value is on this? It's a number. No, it's not 1. 1's down here. No, 10's way up here. That's not the average value. 5. 5 is the average value. Well, it's y equals x. At 0, I'm at 0. At 10, I'm at 10. So by, what is it called? Well, no, what's the average? If I take up all values from 0 to 10 and the distribution is even, then what's the middle between 0 and 10? 5. So the average value is 5. But I just don't want you to take my word for it. The intuition is the word that I was looking for. What's your intuition telling you when this is 0 and this is 10? That the average value between 0 and 10 of this function is 5. Cool or not cool? I want you to notice if I find the area under this curve and I divide by 10, I better get 5. Look at this. This is just a triangle. What is 10 times 10? 100. 100 divided by, well, how do I find area of a triangle? 1/2. What am I doing? 10, 10. Yeah, but 10 times 10, what is this?
1/2 base times height.
1/2 base times height. The base is 10, the height is 10.
So 50.
This is, oh yeah, 50, and then you divide it by 10. This is 50, that's the area of this, but then look, it's between 0 and 10, and then so I go 50 divided by 10, and that's 5. Chav, what did you just do there? All I did was this formula right here, guys. This formula right here. So look, 1 over 10 minus 5 integral from 0 to 10 of f of t dt. And I'll slow down, guys. I'll slow down. This that I'm circling in orange was this 50 that I just got. And then I take that 50 and I multiply it, or I guess I can also say divide, and I multiply it by 1/5, or you can say divide it by 5. Oh, 10 minus 5. 10 minus 0. Man, I'm all over the place today. I'm sorry, guys. You guys deserve better. 50 divided by 10 is 5. Yeah, I'll slow down. I'll slow down. Okay, yeah, let me start again, because maybe it's me. Oh, it is me. I know it. All right, so all I'm trying to do is, so let me slow down. So if I have a linear line, so I was trying to prove this. This linear line is just a linear line from 0 to 10, and I notice that my interval is 0 to 10 on the x-axis, and then I notice that my highest value, the lowest value is 0, and the highest value is 10. And what I was trying to start off with, start off by saying, what does your intuition tell you that your average y value is? Well, if my lowest value is 0 and my upper value is 10, and I'm going from the x0 to x10, the average value is probably right smack in the middle between 0 and 10, which is 5. So the average value of this is 5. And then from there, I tried to say, well, that's your intuition. Now let's do it mathematically. So you see this formula here that says average of f 1 over b minus a? So if I were to go 1 over, and your a is 0 instead of 5, I don't know why I did 5, 10 minus 0 integral from 0 to 10 of f of t dt. You see this that I'm circling? That's just the area of that triangle. Area of that triangle, don't worry, I see this. 10 times 10 is 100, divided by 2 is 50, so this is just 50. So I have 1/10 times 50. Are we still okay? And then what is 50 divided by 10? 5. So there it is. We just proved it mathematically that the average value of this expression, y equals x, is 5. So that's the same, and maybe I should have done this example better. You see how this says 5? If I were to put 0 to 10 there, look, this average value, this area here is the same as this area here. 5 times 10, 50. Oh, look, 10 times 10 is 100, divided by 2, 50. So this area here will fit perfectly into that area there. The average value is just 5. What's up, Houston?
Whenever you put 1 over 10 minus 0, what values were you using?
The upper limit and my lower limit of wherever I'm trying to find the average of x values. Hit me, guys. Hit me. Are we okay, Rodriguez? Kyle, did all that make sense or not? Yeah. All right, guys. So let's see what your intuition tells you. I'm going to go slow. Vega, do you got any questions? You see this x cubed? It looks like this, guys. I'm going to go slow. Here's -2. Here's 2. What does your intuition tell you about the average value between -2 and 2?
0.
Yes. How did you know it was 0? Because this area here below the x-axis cancels this area here above the x-axis, so the average y value between -2 and 2 must be 0. Do you guys see that? Okay, now you could have also proved it mathematically by doing this. 1 over, what's my interval? 2 minus -2, integral -2 to 2 of x cubed dx. Look, we're going to, yes.
Shouldn't we be equating, like establishing, like the average of f?
Yeah.
Or something?
Yeah, I should. That's good habits.
Is it like the same way in which we have to always write limit? Never mind.
No, well, yeah, like when you're finding limits, we would always write the word limit. Yeah, I should write average of f. What's up, Vega?
So is the
You're correct, miss.
always going to be the midpoint, or is it?
No. It just depends on your areas, right? Like if I had more area on the right hand side than the left hand side, then my average would skew more to the right. But since my areas are equal, they cancel each other out. So 1/4. Let's do some help because we need some help with antiderivatives based off of what I saw. What's the antiderivative of x cubed? No. Perfect. You can say 1/4 x fourth. That's fine. X to the fourth over 4, lower limit -2, upper limit 2. You see this 4 here, guys? I know both terms are going to have a 4 on it, so can I just factor it out? So I'm going to write it like this. 1/16. Does everyone know where that 1/16 came from? It's from this 4 and that 4. Those 4s together, when I multiply it, is 16. Parenthesis, upper limit, 2 to the 4th minus -2 to the 4th. Upper minus lower. Are we still okay? 1/16 parenthesis, and I guess you can already see that 0, but let's just do it the right way. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16 minus -2 raised to the 4th is going to be another 16, and I just get 0. Now it does say here, determine the number c on this interval in which the function is equal to the average value. That's just 0. That just means an x value. What's the x value? Where the average equals 0. Yeah. Yeah, that's it. What's up?
I guess it's just more formatting, but whenever you're going to evaluate at something, do you have to do that with brackets?
Because yes, this is correct math notation. I guess if it's one term, you can get away with just putting a line, evaluate upper minus lower. But I just put that in brackets, upper limit, lower limit. This is probably the way it looks like. It looks the cleanest that way. You know what I mean? Ask me questions, guys. Are we still okay, or we just need more practice? Okay. So here we go. Don't worry, we're gonna do a lot of practice, guys.
So are we behind schedule?
I would say like a week and a half, 2 weeks, but not too. It's not detrimental. Like if we were a month behind, then it'd be pretty bad.
Like what's the furthest one that you've been?
A month. An observer measures, but 1.5 weeks to 2 weeks is not bad. An observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. Use trapezoidal to help you out. What is the average temperature for the 12-hour period? So first, let's just set up an equation. First, set up expression. So, and just like Miss Mia Cruz said, we need a right average of something. So I'm just going to write this right here, guys. Average of something. So here we go. I'm going to write average, AVG, and I'm going to write average of temp equals 1 over the difference between noon and midnight is 12. Integral from 0 to 12 of, and I guess I'm going to write temp dt. Are we okay? Nothing crazy. All right, so this 112, I'm just going to write it right here, guys. 112. And then I'm going to put this here in a bracket. So I'm going to write bracket. And I'm using trapezoids to help me find the area under that curve. And Oyane, that's a demerit, miss. Sorry, miss. I'm not going to write a demerit. All right. Each one of these gaps is 1 hour. So I can just use my trapezoidal formula, even though I'm not a big fan of it. I don't know. You guys tell me. Do you guys want me to use the h over 2 y1 plus 2y2, or do you want me to just do it like one trapezoid at a time? Okay. All right. So my height of all of these is 1. I'm just doing the trapezoidal formula. Parenthesis. And then my endpoints do not have a coefficient of 2 in the front. So I'm going to write 63 plus 2 times, yep, plus 2 times, 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 plus 2 times,
Oh my gosh.
plus 2 times, plus 2 times, plus 2 times, and then this last one does not have a 2 in the front. Do you guys have a calculator? Oh man. See if you guys can grab a calculator, guys. Yeah, she's gonna pass them out. And check that you get the same thing I get.
Did you say chat or check?
Check. Today's my off day, miss.
Okay, everybody has themselves.
See? I think I did.
Oh,
63.
No,
No, I mean,
I did. 2 hours of sleep last
I
night.
got 30 minutes.
oh. You better talk to a doctor.
No, I'm kidding. I was like, I knew.
Oh, no, I get more than 30 minutes. That's a nap. 1 over 2.
3 hours. Your full sleep is my nap.
63 plus 2 times 65. Yeah, hook me up with the temperatures. I'm at 2 times 66 plus 68, 70, 69, 68, 68, 65, 64.
There's so much room for error here.
What was it? 60, 62? 50, 62.
What? Why did you put 1 over 2?
Okay.
It's 1 over 2.
Okay. So right now, what I'm doing, guys, I'm just doing the 1/2 times all of this, and let's see if I got that. I got 785.
What? I got 782.
I got 379.
All right, let me check.
What did we mess up?
68. I feel like a fat
68?
Wait,
let me read up to you again because I totally could have screwed up. Tell me the problem.
All right, let me push enter and second to the left. Okay, so start at the beginning.
Did you have 63?
Yeah,
Plus 2 times 65?
yeah,
Plus 2 times 66?
yes,
2 times 68?
yes,
2 times 70?
yes,
Oh, I
2
didn't
times
think about
69?
yes,
2 times 68?
yes,
2 times 68?
yes.
2 times 65? Yes.
No.
I'm still doing good.
Okay, hold on. I have 368s.
I got 391, guys.
Okay, hold on. 68.
782.
Six. Oh man, maybe I did mess up.
Why did you put the fraction as 1/2 and not?
It was 1/2, no?
Yeah. But what about
Oh.
outside the bracket?
Yeah, I haven't done that yet.
Oh,
63, 65, 66, 68, 70, 69, 68, 68, 65, 64, 62, 58, and then 55. Okay, so 782.
Yeah.
Okay, now I take that 782 and I divide it by, divide it by 12 or multiply by 112. 65.16666.
There is no girl inside. I don't know what you're talking about. Wait, what's the answer? How'd you get 6?
Okay. Now, sometimes I give you guys these exams, and I can tell sometimes, or it could also be because we're just in a hurry, but try to make sure that it makes sense. That's 65.166. It is between these, and yeah, that looks like it could be an average temperature. Now, if you were to get a number like, let me look, what's the lowest? Okay, if you were to get a number like 40.333, can it be 40.333? No, guys, you weren't even close. That's a 55, that's a 63. It has to be a number between. Sometimes you give me a number like 74.766, and then you read a statement. The average temperature is 74.766. Guys, the warmest it got was 70 degrees. There's no way you can get to 74. Do you guys know what I mean? That happens all the time on exams. Look, I'm telling you guys right now, and let's see if it happens. If it happens, I'm going to call you out in front of everyone.
Oh.
Yeah, that is messed up. FERPA. I can't do that. But yeah, that's what I said. That's why I took it back. FERPA.
Oh, but you can tell everybody that I was 1 point away from.
No, you did that. You did that. You
No,
did that.
he
I
said-
actually have that on video. You did that, and I'm like, FERPA, miss.
No, he did. He said one person was 1 point
But I didn't even
away,
look
and
in
I
your
was
direction.
Yes,
I was
you did.
like-
No, yes, you did. And I was like, no, that was me. I'm still upset over that 1 point.
All right,
I'm
time
still
out.
upset over that.
You're fine. Miss. You're fine. All right, look at this, guys. This is from, and by the way, these kids had the whole year. This is from the 2016 international exam. Only 44% of test takers got this correct, and that's what they had the whole year. Do you guys want to give this a shot and see if you can get it correct with what little we know, and see if we can get it right? Okay, no calculator. Take a 2-minute headshot. Head start. First, do the formula. Do the setup.
Is it just Ellen? Ellen West? I'm confused.
Do the formula, Cruz. What might stop us is the algebra. If you're still going, if you think you're going in the right direction, keep going. I'm going to just get started here. I start first by writing the average formula. Tell me what's the average formula, guys? 1 over
6 minus 4.
integral.
Integral 4 to 6 and 1 over x. dt.
I'm going to put X. Not a big deal.
Same difference.
Are we okay? This is no calculator, so you don't have a calculator to help you out. So here we go. 6 minus 4 is just, so I'm going to write 1/2. That 1/2 is from here. Are we still okay?
Yes.
I put a bracket, and inside that bracket, I'm going to write my antiderivative. What's the antiderivative of 1 over x? ln of x, and then I close my bracket, and I put lower limit 4, upper limit 6. Did you get up to here at least?
Yes.
Okay, now I'm going to do algebra. You can, if you want, include the half on both the terms, the upper minus lower. But since they're going to be on both terms, make life easier for yourself. Leave it factored out. So here it is. 1/2, leave it alone. Bracket, ln, upper minus lower, ln of minus ln of 4. You are done. Now it's just see if you can do algebra properties. So this is 1/2, big parenthesis. And since I have a minus, this is going to be ln of 6 over 4. Initially, you don't see it in there, but this reduces. 6 over 4 reduces 2. So 1/2 ln of 3 over 2. So what's the answer? C. You could have also seen it. I'm surprised that they didn't do it, though. If you would have seen this, ln parentheses square root of 3 over 2, that would have been a valid answer also. But they decided not to test your algebra skills. Because that 1/2 goes to as an exponent. So just be careful of that. Cool or not cool? Okay. All right. Let's go to the next one.
Are we just doing sample questions now?
Yeah. This is what we're doing next. U sub. Do you guys want to see the preview now, or do you just want to wait till tomorrow for this one?
Just do it now.
Okay. So here's how this looks. It says, what is the average value of f of x sine x cosine x on the closed interval 0 to pi over 2? So I'm going to write average of f of x equals 1 over pi over 2 minus 0 integral from 0 to pi over 2 of sine x cosine x dx.
Oh shit.
I kind of feel like, well, I already said I was, so I'll just do it. All right, it's okay if it doesn't make sense to you. Relax. We're going to cover this. If everything goes as planned today, we're going to cover this tomorrow. If it doesn't go as planned today, then we'll move it to a Wednesday. So that way we can practice tomorrow. This is called U substitution. I see a sine and I see a cosine. So I'm going to write the cosine. I'm going to write the sine first. I'm going to write U equals sine x. Chav, what are you doing and why are you doing it? So let me explain what I'm doing. Right now, with what we know, there's no way we can take the antiderivative of sine x cosine x. But we can transform this into something that we can. And this is called U substitution. So what am I doing? So I'm saying that U equals sine x. And then look, right next I'm going to take the derivative of U with respect to x, du dx, equals what's the derivative of sine x? And I just write cosine x. Get up to here. Is everything making sense so far? No, the derivative of sine is cosine. The derivative of cosine is negative sine. I'm doing derivatives. Are we okay so far, guys? All right. You see how I have cosine x? And okay, let me put this in brackets. You see how I have cosine x dx right there? So if I multiply the left side here by dx, and whatever you do to the left, you do to the right. And then look, I have something that I can substitute. du equals cosine x dx. Do you guys see that? So I can substitute it and get something simple. So look, watch. Equals 1. Okay, this right here that I'm circling, 1 over pi over 2, that's just 2 over pi, right? 2 over pi. Integral, do not put limits because now I'm changing my domain. Instead of x, it's a u. And look, what is sine x? U. U. What is cosine x dx? Du. Look at that. And can I do the antiderivative of u? Yeah. Now my new lower limit, I know, look, this is in terms of x. I need a new lower limit. So I plug it in here. What is sine of 0? 0. So I put a 0 for the bottom. So that one doesn't look like it changes. What is sine of pi over 2? 1. Now tomorrow, I'm probably going to ruin my joke by telling you guys now, but tomorrow I'm going to say, guys, it's about you, not about your ex, and you have limits, and you don't go back. No, this is actually true in real life too, because they're an ex for a reason. You don't go back to your ex. You're just asking for trouble. Like they're an ex for a reason. So whenever you see a definite integral, you're not going to go back to your ex. You're going to stay in you.
Okay.
So look, here it is. Yeah, we'll do it tomorrow. All right. Sorry, miss. What's antiderivative of u? No. U squared over 2. Antiderivative of u. Yeah, we're not going back to the x, guys. U squared over 2. Lower limit is 0. Upper limit is 1. I'll wait for you guys to catch up. I just did antiderivative. I just did antiderivative of this integral. Added and divide by the number. That's why I said we need to practice more. So I can get the average value.
This is so funny.
So let's say if instead you were like taking the u and the cosine, then
I would have to add a negative on that.
Oh yeah, but like if we were going to do this,
Yeah, cosine 0.
Okay, so whatever they plot it, whatever like thank you.
Yeah, this is why I told you guys if we wanted to do this one now or later. This is the equivalent of value as my expression over here in terms of x. So there's no reason to go back to the u. We're just going to solve this. I don't need that 2 in the bottom. Both terms are going to have it. So can I just take it out?
Yeah.
So look, the 2's cancel out, and I get 1 over pi. And all I'm doing is upper minus lower. 1 squared minus 0 squared. Are we still okay?
So we just won.
It's just yeah. 1 over pi.
All that's 1 over pi, don't get.
Yeah, you're gonna. Oh, this is nothing. Let's wait till you get to engineering school. Wait till you do Laplace transforms.
What happened at 2 plus 2 equals
2 plus 2 still equals 4.
4?
All right.
Me when I lie, bro. Me when I lie.
Let's go to the next one.
Wait, tell me everybody, bro. That was a good one.
I was trying. All right. Suppose that b is greater than 0, and the average value of 5x minus 3 on 0 to b is 1/4. So they're already telling me what the average value is, guys. Are we okay? All right. Find the value of b. So here it is. I'm going to write average of f. I'm start by setup because this is more algebra than anything. Equals 1 over b minus 0 integral 0 to b of 5x minus 3 dx, and all this equals 1/4. This is more algebra than anything. Can you do the setup right here? Okay, so then here we go, guys. 1 over b bracket, what's antiderivative of 5x?
5 squared.
What's antiderivative of 3? Close it, 0 to b, and all that equals? Now it's algebra. No more calculus. What's up?
How do we know we don't have to do like the plus C?
We don't have to do plus c because this is the definite integral. You only do the plus c when it's indefinite, when there are no limits. You know what I mean? Are we still okay, guys? I'm just going to plug in an upper. Do I have to worry about the 0? No, because anything times 0 is. So here it is. I have 1 over b, and I guess for now I'll still have that brackets here. 5 halves b squared minus 3b, close it, equals 1/4. I'll wait for you guys. Don't worry. Are we still okay? Okay. I did upper minus lower, but the lower I didn't have to worry about because it's just 0.
Wait, so that's a 6?
That's a b. That's a b. That's a b. That's a b. Yeah. Let me get my laser. That's a b. That's a b, and that's a b.
0 to B.
Yeah, I have to pay extra for that.
0
Okay.
to B, right?
Yeah, well, zero to b, but if I use a 0, anything times 0 is 0.
That was a 6.
Oh, sorry, miss. Yeah, that's a b. This one over here is a b. Oh, that's not my laser anymore. Sorry, I thought I had my laser. There, that's a b. All right, here we go. Ready?
Yes.
I'm going to factor out a b. Do you guys see that? So I have 1 over b times, here's my b factored out, so that's going to turn to 1. Yes.
Yeah, why didn't it be 1? So
Yes.
The only one that we worry about is that b squared.
You guys tell me that you guys want more steps, and then do you guys want less steps?
Okay. No, I need less steps.
I feel like that's a 1. Like, yeah, that's a 1, but I'm trying to put all the steps as possible.
Oh, and then we just add.
Okay, so now these cancel out, just like you guys said. And I have, so let me come over here. So this is 5 halves b minus 3 equals 1/4. Now it's just algebra. What do I do with that minus 3? 5 halves b equals, let's see, 3 and 1/4. 3 times 4, 12, 13. Yeah, 13 over 4. And then how do I get the b by itself? Multiply by the reciprocal. Multiply by 2/5. Whatever you do on one side, 2/5. So here it is. B equals 2 goes into 4 twice. So 13 over 10. Do you see how we did it, guys? Don't worry. The reason why this is so many pages is because pictures take up a lot of space. So we'll go through it pretty quick. Yeah, you can already see what's going to happen here. This is from Delta Math. The regions A, B, C, and D in the figure below are bounded by the graphs of the function f and the x-axis. The area of region A is 4, so this is 4. The area of region B is 11. The area of region C is 19. And the area of region D is 13. What is the average value of f on the interval -5? So here's -5, all the way to 7. So we don't even need the region between -8 and -5. You guys ready? Set up the expression first, average of f, equals 1 over, hey, don't know yawning.
Sorry.
7 by, oh. Oh. Montalongo. Negative 5 to 7 of f of x dx equals 7, 8, 9, 10, 11, 12. So this is 1/12. That's from here. And then I'll put bracket, and I'm just going to add up the areas. If they're below the x-axis, they are, and if they're above the x-axis, it is. So here it is. From I start at negative 5, and I go towards 11. So 11 minus 19 plus 13. So let's see what that is. 13 plus 11, 13, 23, 24, 20. And the difference between 24 and 19 is 5. So 1/12 times 5. So 5 over 12. How do we feel?
That one was.
Wait, why did you do bracket and then parentheses on the 5?
Oh, it doesn't matter. Yeah, to be consistent. Yeah, we need practice with doing antiderivatives by hand. So I did put a subset of antiderivatives by hand, polynomials. So try to use the correct notation, guys. Let f be the function defined by, and there's my f of x. What is the average value of f on the interval negative 1 to 1? So I'm going to go slow, and you guys stop me if we're doing something that we haven't done before. Average of f equals 1 over 1 minus a negative 1 integral negative 1 to 1 of parenthesis negative 2x squared minus 3, close it, dx. Are we still okay? Okay, equals, and I'm going to keep it consistent, 1 over 2, that is this guy. Now, okay, time out. Sometimes you guys will forget about the front and you just start evaluating the integral and you put an equal sign. If you're going to evaluate the integral, guys, put it somewhere in the corner because that's called the linkage error. Do you guys know what I mean? Like, okay, don't write this down. Sometimes you guys will do this. Negative 2x cubed over 3 minus 3x. It's not true because you missed that part. That's a linkage error. So if you're going to evaluate the integral somewhere else, then put it somewhere on the side where the reader will not count it as a linkage error. Do you guys know what I mean? All right, so here it is, 1/2, and I'm going to write bracket, because there's two terms. Antiderivative of negative 2x squared is negative 2x cubed over, perfect, minus, close the bracket. I put a negative 1 in the lower, and I put a 1 in the upper. Are we still okay? Okay, so here it is. I'm going to color code it. I'm going to put this in blue. So here we go. I'm going to go 1/2, and I'm going to go slow, equals. So that just means I'm still doing this. 1/2, and then bracket. I'm going to put all that in blue, guys. Upper minus lower. So I'm going to put a parenthesis first. When I put the 1 cubed, that's still going to stay as 1. 1 times negative 2? Negative 2, so that's going to be a negative 2/3 there. And then 3 times 1, that's still going to be a, yeah, so there it is. That's my upper. Minus, open parenthesis, negative 1 to the 3rd, that's going to be a negative. Negative times a negative, so that's going to be a positive 2/3. And then 3 times negative, or negative 3 times negative 1, plus.
Will we distribute that negative?
Yes. Here we go. 1/2 bracket. Let's see. I'm going to go ahead and just write. I'm going to just drop the parentheses down and I'm going to distribute this negative and see if anything cancels. Negative 2/3 minus 3 minus 2/3. Nope, doesn't cancel. Minus 3. So let's see what that finally is. 1/2 bracket. Negative 2/3 minus 2/3. That's a negative 4/3. And then negative 3 minus 3. That's a minus 6. And then since we don't have calculators, well, we're not supposed to. That 6 is the same thing as 6 times 3 is 18 over 3. So negative 4 over 3 minus 18 over 3. What's 18 plus 4? 22. So 1/2 negative 22 over 3. And then finally, positive times a negative is a negative. So, and I see the 2. 2 goes into 22 11 times. So my final answer is negative 11 over 3. Whew, that was tough.
You can calculate area between curves.
Yes. Do you think we've done too much and you want to hold this till tomorrow?
No. I think we should stop. Like, I don't know why.
We should stop?
No, I think we should stop like pushing so back. Like stop like.
Yes,
Oh, so-
I agree.
Keep it as like we're
Just keep
behind,
going.
behind.
Oh, so just keep going?
Yeah.
Okay. Don't worry, guys. The concept's pretty straightforward. Look, the concept's pretty straightforward. It's not going to be that bad. You remember how we did? Check it out, Miss Kyle. You'll be fine. So whenever we found area of F, so I'm going to call this F. If I told you this was A, relax. How do we do that? We did A to B of f of x dx. Yes or no? Okay. So now what if we have two curves? No, stop. The concept's pretty easy. You're not gonna freak out. I don't think you will.
You just add areas.
What if I want this area here? I'm gonna say this is A, and I'm gonna say this is B. I'm gonna go slow. What if I want this area? Okay, relax. Check it out. Ready, Kyle? If I told you, maybe I should have just started with this. If I go area from A to B of f of x dx, yes, but can you do it in one integrand? So the area under the curve of x is that in red, yes or no?
Yes.
The area under the curve of g of x is this in burnt orange. Maybe I should have done it in purple, but that's fine. Do you guys see that? But I don't want that. I want this area. So all I got to do is take the red and subtract the orange. So the one in black, I can go integral from a to b of f of x dx minus area under the curve, just like Miss Vega said, a to b of g of x dx. Now, property of integrals are my lower limits and upper limits the same. So I can rewrite this as one integral from a to b of what minus what? Don't forget your differential with a dx. And yes, your professor might do Riemann sums here, where the rectangles are right here like this. See? Let's do it in purple. Your professor might do it. MIT, if you go to MIT, they might do it. If you go to A&M, they might do it. Just be prepared. We're not going to make you do it. But we are going to make you do this. Did all that make sense, guys? Okay. We're going to go slow. I'm going to go slow, and I need you to stop me if something does not make sense to you. Okay. It says fine. Okay, I'll wait. Is everyone okay? Okay. Yeah, I'm going to go slow. Okay. So look, let's read. It says, find the area of the region between y equals secant squared x and y equals sine x from 0 to power 4. You guys like visuals, so here's the visual. That I want to find that area in blue, the shaded area. Are we okay so far? Okay, here we go. All I'm doing, I like to write a line to see which one's on top, which one's on bottom. I know it doesn't make sense for this, it is easy, but later on we're going to be integrating with respect to y instead of x. So the curve that's on top is secant squared. The curve that's on bottom is, so I'm going to go integral. What's my lower limit? Where do I start? 0. What's my upper limit? Power 4. Secant squared x minus sine x dx. I would prefer that you put parentheses, but it's not necessary. What's up, Vega? No, I just draw anywhere a vertical line. What's on top? What's on bottom? Just to signify what's on top, what's on bottom. I'm not partitioning it or anything. Later on, we'll see why. What's up, Miss?
How do you know to use the x values and not the y values?
I'm integrating with respect to x. These are all my rectangles. Are all like this. They're all. So I'm doing with respect to x. Later on, we are going to integrate with respect to y, though. Are we okay?
But they'll tell us, right?
You'll see it based off of how the function looks, how the graph looks. All right, we're going to go slow. All I'm doing is area under the curve. What's up, Kyle? What is the antiderivative of secant squared? Tan. Yeah, because the derivative of tan is secant squared. Do you guys see that? What is the derivative of sine? So I'm going to write plus cosine x. Does everyone know why it's positive cosine x? Okay. Yeah, you can always go like, well, the derivative of cosine is negative sine. You can see that it goes backwards. Since I have more than one term, I put these in brackets. I put a lower value of 0. I put an upper value of power 4. All I'm doing, there's nothing to factor out here, guys. You can't factor anything out. Upper minus lower.
So can we just forget about the 0?
No, because cosine of 0 is 1. So here we go. I'm just doing upper minus lower. Giant parenthesis. What is tan? Do you guys want? Okay, let's go. Let's put all the tan of power 4 plus cosine of power 4. Close giant parenthesis minus open parenthesis tan of 0 plus cosine of 0. I wasn't going to do that, but I decided to do it last minute because that way you guys can see all the steps. Equals giant parenthesis. What's tan of power 4? 1. Plus cosine of power 4. You got to know a little bit of pre-cal, guys. Not extreme, just a little bit, but you got to know it, guys. Minus, open parenthesis, what is tan of 0? 0. Tan of 0 is 0. Plus, what's cosine of 0? 1. Close it. All right, let's see. There's nothing in front of this parenthesis. I can just drop those parentheses. 1 plus square root of 2 over 2. Minus 1. Perfect. Square root of 2 over 2 is the answer I'm looking for. That's it. That's the area between the curves. How do we feel? Don't worry. Don't worry. We'll be fine. These are the last two. All right. Ready? Find the area of the region enclosed by the parabola 2 minus x squared and the line y equals negative x. Here it is. I need to find these intersections. Chav, how do you do that? Like this. So let's do it. Let's do this by hand, guys, so we can get some experience. I'm going to go 2 minus x squared equals negative x. Now what, Chav? I'm going to move the negative x squared and the 2 to the right. So I have 0 equals x squared minus x minus 2. Now I'm going to factor out 0 equals two numbers that when I multiply give me negative 2, but add up to a negative 1. And which one's the bigger one? I mean, where do I put the negative one? On the 2, the bigger one. Are we still okay? All right, now I'm going to solve for where this is 0. I'll slow down because I can see some of you guys writing. I want to find the intersection. So here it is. X equals 2 and x equals negative 1. This is going to be my lower limit. And you can see it on the graph there. And that x equals 2 is going to be my upper limit. Cool or not cool? Okay, here we go. Integral. Negative 1 to 2. Okay, now what? Which one's on top? The parabola or the linear line? The parabola. So I'm going to write it out for now. 2 minus x squared like that. And then which one's on bottom? Minus x like that. And negative x. Or else I would have gotten a wrong answer. And don't forget your differential. Are we still okay? Okay. I like to rewrite this with the highest degree first. So let me rewrite it. Negative 1 to 2. And I'm going to write negative x squared. And then what's minus a negative x? So plus x plus 2. Have I lost anyone? You can go slow, guys. You can look right here if I distribute this. 2 minus x squared plus x, all this like that, dx, integral. But I'm just writing this one first, and then that one, and then that one. Negative x squared plus x plus 2. Okay, here we go. I'm going to go slow. What's the antiderivative of negative x squared? Over. What's the antiderivative of x? What's the antiderivative of 2? Put all that in brackets. Lower limit -1. Upper limit. Yes, you can do it with a calculator. We'll do it in the calculator in a little bit. Remember, we just need practice on this. Upper minus lower. I'm gonna put the equal sign, giant parenthesis. This is gonna stay negative, guys, no matter what, because of that negative symbol. So I'm gonna open up another parenthesis because I'm just doing upper minus lower. 2 to the third power is 8. Put the -8 there. -8 thirds. Plus 2 squared divided by 2 plus 2 plus 2 times 2, 4. I don't see any issues. Let me check. 2 squared, 4, 4 divided. Okay, close parenthesis there. Minus, open another parenthesis. -1 to the third stays negative, but negative times a negative is a, so put 1/3. -1 squared, yeah, just 1. So plus half. And then 2 times -1, -2. All right, you're done. Now it's just arithmetic. See if we can figure this out. So let's see, giant parenthesis, little parenthesis. 4 plus 2 is 6. So let me see. I'm going to write it like this for now. -8 thirds plus 6. Close it. Hello, guys. Minus, open parenthesis. Let's see. I guess we're going to have to just do this right. I'm going to multiply this guy by 2 over 2 because I'm getting a common denominator of 6. And I'm going to multiply this one by 3 over 3. Oh, yeah. Ask me. Oh, we're good? Okay. So here's what I see. -2. That's this one right here. And then I see 3 plus 2, which is plus 5 over 6. Do I still got some room? I do. Now I'm just going to finally add them all up, guys. I'm just going to drop the parentheses and distribute the negative. -8 thirds plus 6. Are we still okay? Plus 2 minus 5, 6. I look at that 8 thirds. I'm just going to double it. Times 2 times 2. What's 8 times 2? So -16 over 6. Okay, so now we're ready, guys. Here we go. So 6 plus 2 is 8. 16 and 5. 16, 17, 18, 19, 20, 21. Minus 21 over 6. Does 6 go into 21? It does not. What's 8 times 6? 48. So 48 over 6 minus 21 over 6. 48, 38, 28, 27. We'll check to see if we made any mistakes. All right. You guys ready to do the calculator? Look, they kind of cheat. You see right here where it says y1? Type that into y1. 2 minus x squared. Let everyone try, guys, so we can make sure that we know how to do this with a calculator. So clear. Yeah, if you have junk in there, clear it, guys. Y1, I'm going to type in. Where am I going to type in? 2 minus x squared. And then y2, what am I going to type in? Okay. All right, go to the home screen. Push math. Push number 9. From what to what? -1 to 2. Okay, what equation was on top? The parabola or the linear line? So type in parabola. It's on y1. y1. Minus the linear line, so y2. And then just push with respect to x. So does everyone look like that? Don't worry, I'm waiting.
No, I'm taking my calculator.
Oh, okay. And look at that, 4.5. Let's turn that into a fraction and see if it's the same fraction that we got.
Yeah, it isn't. It's like,
Oh.
yeah. Wait, if you simplify this though. Okay, yes. It is the same. Yeah. It's the same.
I was already getting sad. Oh yeah, 3 goes into 27 9 times, and 3 goes into 6 twice. This is 9 over 2. Cool or not cool? All right, last one, guys, and then we'll call it a day. On this one, let me see.
So
Breathe.
All right, let's see if this one is a pretty number or not. Let's see. Well, let's see. Let's see. 2 cosine x equals x squared minus 1. Oh, yeah, it's not going to be a pretty number. You got to use the calculator. Type this into y1. Type this into y2. What was y1? 2 cosine x. 2 cosine x. What was y2? On this one. All right. Do you know which equation is which? How do you know?
Wait, possibly not.
Oh yeah.
Yeah, x squared minus 1
is the problem.
Yeah.
X squared minus 1 is this parabola that's opening upward.
Yeah.
And this one right here in the top is 2 cosine x. So here we go. You got to find the intersection. How do we find the intersection? Well, you see this right here, negative 3 to 3 and negative 2 to 3? So that's what I'm going to put my window. X min, negative 3 to 3. Let's see. And y min, negative, what was it? Negative 2 to 3. And I'm going to put y scale 1 here. Graph. I'm going to tell the calculator to find this one for me. I'm going to call it A. It's actually symmetric on the y-axis, so those two should be the same, except this one's negative, that one's positive. But I'm going to call it A and B nonetheless. So second, calculate number 5, intersect, enter. So this is, okay. Remember when I told you that I like Desmos, but you see how on this one I'm saving stuff into the calculator? Whenever you're saving stuff into the calculator, I like the calculator better because you have the watered down Desmos on the AP exam. So you're not going to be able to save numbers. Does that make sense? So anytime you have to save something, use the calculator, guys. So practice with me, guys. Second, calculate number 5, intersect. When it says gas, push enter. You see how it says intersection there? I'm going to go to my home screen and I'm going to go X, store, and I just go down the alphabet. A. So now that intersection's A. Cool or not cool? Okay, then I'm going to do that again. Here's my graph. I'm going to get the other one, guys. Second, calculate number 5. Enter. And then when it says guess, scroll to the right. Okay, that's the one you want. And then push enter on that. And it needs to say the word intersection. It's the same value, but positive. So here we go. I'm going to quit, and I'm going to go X, and I'm going to go down. What letter do you think I'm going to use? I just go down the alphabet. Now, on the AP exam, what do? So you do this. This is for notes. So do not write Y1, Y2. Some of you did that on the AP exam. Stop. I'm not looking at you, miss. Okay. All right. Here's what you should do. You do the setup. This is called a setup. 2 cosine x equals x squared minus 1. And then you tell me where they intersect. X equals negative, and I already forgot.
Negative 1.265.
Give me more digits.
2, 3.
7. And then I'm going to go arrow A. You can actually also put equals. And then I'm going to write x equals 1.2654237. And then arrow. And what letter do I put for that one? B. And now you can use A and B and reference them all you want. I like capital letters. You'll see the rubrics. Sometimes the rubrics have little letters. I just like capital letters, and I just use capital letters all the time. Cool or not cool? All right, here we go. I'm going to go. The area of this is area from what to what? A to B. We already used it. You already have it here. A to B. So you told the reader what's A and what's B. And then what curve is on top? 2 cosine x minus, and I'm just going to put it like that in parentheses. What's the curve on the bottom? Close it. I'm not going to bother distributing. I'm going to leave it like that. If you want to put another parenthesis like this, guys, just to, because it bothers you, because it's always width times height, go ahead. And now here we go. I'm going to take my calculator. Notice it doesn't say y1 or y2. I'm going to go math, 9, alpha A. Practice, guys, practice. Alpha B. And then alpha trace y1 minus alpha trace y2. Practice with the calculator, guys. 4.9949. Our answers might differ by a little bit after the fourth digit, but we should at least have the first four is the same.
99490.
Oh, my bad. 490. Is yours the same as mine? Okay. 99490.
And we could just stop it right, we don't round.
Yeah. And there it is. Can we do that, guys? Okay.
Yes.
I don't have practice on this just yet on Delta. I just have practice for the top half. But that's it, guys. And then tomorrow we'll probably just do some practice since we took care of this today. So tomorrow during lab, we'll just practice a whole bunch. Cool? All right. There's a Delta if you want to log in and do it for a little bit. You can take a 2-minute break, but make sure that we take care of our Delta, guys.